Hello guys, in this video I'm going to show you how to solve longest subarray with ones after replacement. Given an array containing zeros and ones, if you are allowed to replace no more than k zeros with ones, find the length of the longest contiguous subarray having all ones. Okay, so for example, with this given input, we have an array that contains only 0 and 1, and k2 it means we have at max 2 replacements, right? We can replace uh, 0 by 1, right? So for example, consider this subarray. It has two zeros, right? So it means I can, because k2, so it means I can replace at max two zeros. So with two zeros are replaced by one, I will have a contiguous subarray with all ones, right? So but here we are required to find the length of the longest contiguous subarray instead, right? And let's say we have five with this subarray, but if I expand this subarray one more character to here, then now I have three zeros, right? And I have three zeros, but I only have two replacements. So for this subarray, I cannot build, I cannot find valid subarray, right? So for this, the original array, you can see here the maximum array has a size 6. So explanations replace 0 at index 5. Here is index 5, right? And index 8. Here is index 8. Then this subarray will become all ones. So it has size 6, right? So the final result is 6, which is the longest subarray after replacements. Okay, so for this kind of problem, where we need to find a subarray that uh, that need to satisfy a certain constraints. In this case, it has no more than k zeros, right? So this kind of program will fit into sliding window category, right? With sliding window, we can easy check different possibilities, and we can adjust the window, either expand or shrink it down. We will expand the window when we want to find a longer subarray, and we want to shrink it down when when the current window is not a valid one. So uh, let's let's try to run it manually here. uh, okay, for sliding I need to um, actually we need to first we try to translate the original problem into something that is easier for us to proceed here. So actually here find the length of longest contiguous subarray having all ones after replacements, right? So here I think we can translate it into find the longest subarray that has no more than k zeros, right? Translations, find the longest subarray with maximum of k zeros, right? So with this, given these translations, I think we must keep an keep a count of zeros, of how many zeros we currently have in our window. So let's we need a variable zero count, for example. All right. So here we start a window at the first number. We have two pointers pointing to the first number. So I will increase our count, zero counts, by one because the first number is zero. So at any given point in time, we have two choices, either to expand or to shrink down the window. And because we have at max two zeros to replace, and the number of zeros now is one, so it is still fine. The current window is still a valid one. So probably I want to incrementally update the longest subarray, the longest subarray size. Um, so here, because the current window is a valid window, right? So I can update the current longest subarray to the current window size, which is one. So now I will expand the window. Uh, is now the newly added number is one. So I don't I will not update the zero count here, still one, and the current window size 2, and it is a valid window, and so I should have this one update to the current window size. Okay, the current window is still good, so I decide to expand it. So I have two ones now. The zero count is still one. The longest subarray is updated to 3, which is the current window size. Now I will expand one step further. The zero count is 2 now. And before updating, I need to check how many zero counts currently in the window and what is the maximum zero in the current window. The maximum I can have is 2, and the number of zero counts now is 2. So current window is still valid, so I can update this side to 4. Now I will, because at this point it's still valid, so I can expand it to find better window. But now zero count 3, and I only have 2 replacement here, so probably the current window here is not valid. So I decide to shrink it down. So because I move the left pointer, and by doing that we have 1 0 removed out of the window, and now 0 count 2, and it is a valid window now. But the current window is no better than this longest Subarray size, which is also 4, so I don't want to update it because the current window is still valid, so I can expand it. Okay, once again 0 count 3, and 0 count G, so it is not a valid window, so I need to shrink it down. So even when I shrink it down, the 0 count is still 3 because the number that is removed from the window is 1, so 0 count is still 3, so I need to further shrink it down. It's still 3 here, so once again I shrink it down. Now it becomes 2. We have 2 0 in the current windows, and it is a valid window, but it is no better than the longest Subarray 4 here. So I will expand to find better window. Now we have 2 0, and the size 3 no better than 4. Once again expand it. Now it is, we have 2 0 in the current window. Here is still valid window, but no better than 4 here. I will expand further. Now newly added number is 0, so 0 count is 3 now, and current this is not a valid because 0 count 3 is greater than maximum we can have here, so I will shrink it down. Now we have only 2 zeros in current window, but current window is no better than 4. Expand it. Now here, only until now, we have 2 0 in the current window, so it's valid. And the current window size 5, which is better than longest Subarray size. So I updated 5. So can we find better window? Expand it further. Okay, we have 2 0, and current window size 6, which is better than 5. So update, expand it further, but now the right pointer is pointing to outside of the array, so we can stop here, and here is the longest Subarray size we can find. So I think that's pretty clear what we need to do here. So let's try to translate these kind of logics into coding. So when I use sliding windows, so I will need two pointer window start and window end. For window end, I will use a for loop, right? Window end will run from 0 to the last index, which is array length -1, min array uh, I plus plus, not I, sorry, window end instead, right? Another thing we need to keep track of here is zero count, is zero here initially, and we need the longest subarray size as well. Longest subarray size initially is 0, and this is something I will return at the end because it is what we need to find. So for one iterations inside here, at the beginning here, at the beginning of this for loop, I want to assuming that the current window is valid window. So I will assumption, we have assumption current window is valid. So I want to expand it to find a better window. Right? So array. So because add I expand it, so let new number will be array at index window n, and if new number is equal to 0, then I want to update 0 count of current window, right? But by expanding the window, our window can become invalid, uh, can turn into invalid state, right? So here I need to check, right? I need to adding new number could make our window invalid, right? 0, what it means by invalid, it means 0 count is greater than k, right? So as long as it's still in the invalid state, which is when 0 count is greater than k, I will need to shrink the window down, right? I will need to shrink it down just by incrementing the start by 1, but before that I will need to check the first number, like for example here the window, the first number is the leftmost number of the window, the first number will be array at window start, and if the first number is equal to 0, so I will need to gonna shrink it down, so this will no longer, it will be, it will no longer be in our window, so I will update 0 counts. Then here is a step of shrinking down. So after it exit this loop is when Ka equal to 0 can or less than or equal to 0 can now. Sorry, I mean 0 count is less than or equal to K now. So here current window is a valid one, so I will consider to update this one longest subarray size. So longest subarray size will be whatever is largest between current longest subarray size and the current window size, which is window n minus window start plus 1. Here is current window size. Alright, I think that is it. Let's run the test. And 8. Hopefully it's gonna be alright. That is awesome. Just to double check. Great. So it indeed works. Right, so that is it for longest subarray with ones after replacement using sliding window technique. So thanks for watching. See you in the next video.